Hello everyone, here we are going to mention the description of the challenges available to us. And I'm Rimaz, I'm explaining about first question. The above mentioned questions details are tabulated in this slide. And final decision maker says that she prefers D to C. Let's argue this statement under the theory of expected utility. First of all, we need to know what is expected utility. Expected utility is an economic term summarizing the utility that an entity or aggregate economy is expected to reach under any number of circumstances. The expected utility is calculated by taking the weighted average of all possible outcomes under certain circumstances. Expected utility in decision theory. The expected value of an action to an agent calculated by multiplying the value to the agent of each possible outcomes of the action by the probability of that outcomes occurring and then summing those numbers. If we talk about the game theory, there should be minimum two decision makers. That is the main thing when we talk about the game. In this case, we can see only one decision maker. This is the first reference that does not fit our theory. Next lacking point in this case is we can see though the color that decision maker chooses randomly the payoff is 1000 LKR. So no incentive to go for techniques as no matter the color she chooses she will get 1000 LKR. Next factor is when we're talking about game theory, the decision made by decision maker should be rational. That ability they have to pick out the alternative that they can get the absolute best payoff. But in order to be rational, there must be a rational decision maker at the other give up of the game. But right here, there is solely one decision maker, and there will be no difference with the rationality or irrationality of the choice. She will receive an equal payoff. Expected utility can't be calculated as the probability of utility cannot be calculated. Here due to the decision makers doesn't comprehend how many black balls and yellow balls are there. All she recognizes there are only 6 black and yellow balls. Based on the above points, the above activity of game does not apply to under the basics of the theory of expected utility. Next question will explain by Padushan. Thank you.
Thank you, Rimas. Now we will move to the question number 2. The second question is all about game theory. Before moving to the explanation of the question, we will look at the question statement very clearly. The second question is, consider the following game. Suppose that players play simultaneous over many periods. In each period, each player best responds to the action played by the opponent the period before. While looking this question statement, we can assume that this is a strategic game. What is strategic game? It means every players who are participate move at the same time. And moving at the same time is called as simultaneous. While looking this matrix, we can see there are 2 players and every player has 3 strategies. Player 1 have up, middle and down. At the same time, player 2 have left, middle and right. In here, the first move of the player 1's payoff matrix is middle left. So player 1 achieved his best probability in this time. At the same time, player 2 couldn't achieve his best probability. So player 2 tried to achieve his best probability in the middle row. Therefore, his best probability is middle right. In here, player 2 achieved his best probability. At the same time, player 1 couldn't achieve his best probability. So player 1 is tried to achieve his best probability in the right column. In here, you can see his best probability is upright. So player 1 achieved his best probability and player 2 couldn't achieve his best probability. So player 2 is tried to achieve his best probability in the up row. Therefore, his best probability is up middle. In here, player 2 achieved his best probability and at the same time, player 1 couldn't achieve his best probability. So player 1 is tried to achieve his best probability in the middle column. In here, you can see his best probability is down middle. So player 1 achieved his best probability, at the same time player 2 couldn't achieve best probability. So player 2 is tried to achieve his best probability in the down row. So you can see his best probability is down left. In here, player 2 achieved his best probability and at the same time player 1 couldn't achieve his best probability. So player 1 is tried to achieve his best probability in the left column. So you can see his best probability is middle left. In here, player 1 achieved his best probability and the player 2 couldn't achieve his best probability. You can see the same strategic profile will appear again and again in the same manner. According to this game, middle left, middle right, up middle, down left are the patterns of the game. So we can find several patterns in this game. That's all my part. The rest of the presentation will be continued by my friend Mahisha.
Thank you, Padshan. Now I explain question number 3. In this situation, there are 3 players 1, 2, and 3. And there are 3 strategies A, B, and C. And there is a special condition in the game. It is if no alternative receive majority when alternative A is selected. Because of this statement, we have to choose the maximum utility of these 3 players that choose A as winner. You can see the matrices in here. In this table, player 1 plays in rows and player 2 plays in columns. Now I explain how A and A is Nash equilibrium. According to these three matrices, we can directly identify ABC is Nash equilibrium, but it is not true, because in this case all these players get highest payoff. According to above statement, we can't give win for A. That is not Nash equilibrium. Nash equilibrium is A and ABA. In the first column, we can see the 2 to 2 as the outcome. In this, all outcomes are equal. In here, we can choose 2 as the payoff. In this second column, we can see 2 and 2 as the outcome. Best one is 2. Therefore, we can choose 2 as the outcome. Then, when comparing the player 1 alternative A, B, C with the player 2 alternative C, we can select the 2 to 0 as the outcome and 2 as the payoff. When comparing the player 2 alternative ABC with the player 1 alternative A, in the horizontally we can see the 0, 0, 0. We can choose 0 as the payoff. In the second row, when comparing the player 2 alternative ABC with the player 1 alternative BC, we can get the 0 to 0 as the outcome. In this, we can select 2 as the payoff. In third row, when comparing the player 2 alternative ABC with the player 1 alternative C, in here 0, 0, 1 as the outcome. We can get 1 as the payoff. When comparing this outcome, we can select first cell in all the three matrices. When considering the AAA cell, payoff is 0. AAB cell, payoff is 0. AAC cell, outcome is 0. All the outcomes are equal. So we can select 0 as the payoff. When selecting ABA cell, outcome is 2. ABB cell, outcome is 1. ABC cell, outcome is 2. Best one is 2. So we can get 2 as the payoff. When considering third cell of all the matrices, AC A cell is 0. ACB cell is 1 of outcome. ACC cell 2 is outcome. So we can get 2 is payoff. Likewise, we can get all the payoffs. The second part of question, payoffs. Payoffs, the game's starting is the best reply to the others is the Nash equilibrium. Furthermore, if pure strategies is a Nash equilibrium. According to that, in here, pure strategies AAA and AAA, AB, AAB and BCC. But in this, AAB is not pure strategy. So, I think AAB is not Nash equilibrium. So we think you can get clear idea about game theory. And this is end of our presentation, and thank you.